extra strong Roman concrete,
fully hydraulic,
structural molded connections.
It's the
structural
Engineering podcast.
Hi, and welcome to this episode of the Structural Engineering Podcast. My name is Max.
And I'm Zach.
We're here to talk structural engineering. We're kicking off this episode with a little news story. This came out just a couple days ago. News from the International Code Council. The story is that the preliminary results on CLT construction for high-rise buildings has been approved. There are 14 new mass timber code changes. We haven't gotten the official results on what this all means, but basically they're saying that CLT, which is a mass timber product, can be used in high-rise construction up to 18 stories tall with fireproofing. The three things that I saw are 18 stories with gypboard, 12 stories with partial gyp, and 9 stories exposed, which is pretty cool. We haven't seen any high-rise wood buildings ever, I guess.
In the United States.
Yeah. This is
Yeah.
something I don't know a ton about.
Yeah.
But Zach is experienced and stoked on
Wood. I love wood.
stoked on wood. But this is actually something that's pretty cool, I think. I mean,
I think it's going to
there's a lot of potential here.
change what the U.S. is using in building materials for mid-rise
Yeah.
structures. High-rises, obviously. I don't think we'll be going to wood anytime soon.
Yeah. I saw a quote from this article, and it said, CLT is a strong low-carbon alternative to traditional tall building materials.
Yeah, so what I've seen, and let's kind of jump into our topic today too, but CLT is almost direct substitute for a concrete-filled metal deck composite system.
And it is a low-carbon material because it traps carbon.
Right, and it's renewable. We can jump into that in a second. But to finish off the story,
strictly with the news.
I think that's pretty cool.
And this will go in the 2021 IBC.
Will be codified there.
Will be codified then.
Oregon just approved in the last year a tall building in downtown. I can't remember exactly how. I want to say it's 13 stories. Similar to the height in the dormitory up in British Columbia, at the University of British Columbia. Mm-hmm. Have you seen pictures of that?
I have seen that. Yeah.
They have a 10 by 10 or 13 by 13 column grid, no beams, no girders, and just floor plate that spans between columns.
Whoa. And
the floor is CLT. Columns are glue lams, and then at the floor level they have a steel tube in there that kind of gives a buffer between the columns. They're not continuous, so that the panels can come sit in there.
Do you know how the ICC defines mass timber in this case?
What? Yeah, so it's using I can't remember the definition completely off my top of my head exactly, but it's going beyond stick framing. So heavy. You're using glue lam columns. You can almost think about it as if you were to take a traditional, let's say, office building with wide flange columns, wide flange girders, and you replace those with wood, right? Those would be huge members. That's heavy timber, more or less, right? You're not talking about your TGIs and your plywood. You're talking CLT, heavy beams, heavy girders, heavy columns, big shapes. I know defining it using the words isn't the best way to do it, but
I guess it's probably where the full structure is made of wood, versus out of components. The entire system is wood,
or majority. Because a lot of these big buildings, you'll find a steel or concrete core.
Okay.
Structure. So it's the gravity system. The main gravity system is heavy timber. So we could go into a little fire. You have your char ratings for mass timber is where you really use it. So you look at you'd oversize your glue lam. So your char rating's about.
We're kind of jumping on the topic here. Did we close out the news? Are we done with the news?
We're almost done.
Okay.
Yeah, I think we're just elaborating on this really
Yeah.
quick, but so like charring, like I think it's 1.5 inches of wood for every hour fire rated. So 1 hour rated, you'd oversize it 1.5 inches. Your glue lam width and whatnot. So that's you're not doing that with your 2x4s, your 2x6s, your 2x material necessarily in these heavy timber buildings. So
cool. So I wonder, in the year 2021, we're saying that we can build big wood structures. I feel like this has happened in the past. People have built big wood structures, hundreds of years ago.
yeah.
Why do you think it's taken so long?
Yeah, I think it's purely an issue of the public thinking that wood is dangerous in tall structures because of fires.
I wanted to look this up, and on the camera, this isn't that, no one wants to look at my phone, but I feel like there's a Japanese temple, I think, made of wood that is 120 feet tall.
Yeah. There's a lot of old structures out there that are like
yeah.
that. Yeah.
And it's wild that it is taken this long to kind of go back in time and say that this is okay.
Yeah, going to like wood seminars, you really like, from what I've heard from the industry, is it is perception of the public. The public doesn't want to see if they don't want to go into a 20-story tower that is made only of wood. They perceive that dangerous. And so I think it's the code. It's trying to drive the code to allowing things that aren't based off of perception, right? Mm-hmm. So like the code shouldn't limit tall wood buildings because people are scared of them. I don't think.
Yeah.
It should allow it, and then it should be up to the developer and the architect to determine those things. But so, anyways, that's a good long news.
Yeah, which is perfect because it leads into the topic we're talking about, which is CLT.
Yeah.
Again, something I don't know a ton about, but
which is good. I want to do we'll do
quiz
a
you
education today and see where my limits are on CLT. Yeah, so we'll jump into it. So CLT, cross laminated timber. I know we keep calling it CLT, but we'll for the rest of the show we'll call it that.
Yeah,
to keep it simple. But
CLT
it's cross laminated timber.
The show would be much longer if we say it the whole way every time.
Gosh, yeah, that'd be a lot longer.
What is this thing?
So it is it's like a panel. It is a panel. They're made in different lengths and widths, but the panel is made up of let's for now say 2x material. So like a 2x6, put side by side and then layered, and each layer rotates 90 degrees. So like we talked the other day on OSB plywood. Yeah. Plywood, since it practically is almost the same idea. Mm-hmm. You're taking sheets and you're rotating them 90 degrees each way. So, and what was the biggest thing with plywood that really helped? Do you remember?
Uniformity.
Uniformity, but shrinkage.
Oh, yeah.
Shrinkage. That's the big thing with plywood, is it restrains itself, and that's what something CLT does. That's a really exciting part about CLT. Right now they make panels, I think 5 inches, 5.5 inches. There's all these dimensions, that different manufacturers use. Different manufacturers use 1 inch to 1.5 inches thick laminations, where they glue them all together. So let's say they put down a whole bunch of 2x next to each other. They'll cover that in glue, put them in opposing direction, cover that in glue, and then they go through this press and presses it all together.
Do they have to be insulated?
No.
Really?
No.
There's enough insulation.
So these aren't being they're not very typically used exterior walls. Now 5 to 18 inches thick of wood.
It's a lot of
probably has some ideas on insulation there, but the common use currently is interior wall panels. Uh-huh. There is houses made out of it, so I don't know what they're doing on the exteriors with it. Most commercial structures, it's the floors.
I imagine shrinkage would be a pretty big concern once you're getting into these high-rise buildings.
Absolutely. So
18-story building, you have a 1/4 inch per floor.
Yeah, so it's not shrinking.
It's really not gonna. Yeah, with
and you
those
mitigate
laminates.
that issue too. So in plan, it's not shrinking, but it may shrink vertically because that's the direction in which that and would shrink, right? So like your sill plate's going to shrink a little bit. So that's where it comes into the detailing of the columns. But so anyways, this material, they come out, they can come out in different panel widths. Common is 8 to 10 feet. 8 is, I think, a very common panel width, and then they can come out as long as 64 feet long.
Well,
More or less, like the lengths are fine because they can go through the machine. It just gets pressed together. So there's a document out, an ANSI APA document, PRG 320. You're gonna anything you ever hear about CLT, that is it. It's the standard for performance rated cross laminated timber, which we need. Everything we design with has standards.
Yeah.
So this is the standard for the material, and all the certified fabrication shops, just like AISC certified shops, are there. There's now certified shops that are PRG 320 certified to make these panels. And so in the last probably 5 years, everything was mostly coming out of British Columbia for these. There is now a plant opening up in Alabama that's going to be certified. There's a plant. It's actually funny. The one in Alabama is called cross-laminated timber, or Texas cross-laminated timber. But it's out of Alabama. And I talked to someone about that company, and they said the reason they did that was because they're marketing to Texas. And like Texans will buy things with Texas
made
in
in
them.
Texas.
So it's kind of funny.
Are they made? They can be made out of any wood. These can be pine, like any softwood, fast-growing wood.
Right. So it depends where it's regional. There's a project in Denver, Colorado, where the client had saw a picture of CLT and it was white. Like the wood was like pale white, and the wood that we have here is mostly comes out yellow looking a lot of times. So that client or that owner of that building actually sourced their CLT from Europe because that's where that wood came out of.
Whoa.
So Europe has been using CLT. Yeah, take a guess. How long do you think Europe's been using CLT?
35 years.
Yeah. It's like 30 years they've been using CLT for everything. Europe has some very interesting construction that they do. There's a whole other podcast I want to have that talks about Germany has developed this system where they make brick looking units out of wood, and they stack and go together like bricks, and then they nail it all together.
Oh, no, okay.
No, they're nailed together, but they're more or less like blocks that you build up, and then they fill them with like sawdust or like something wool, like
Weird. I wonder, is that like a waste product? Like they take the chunks off of wood that couldn't be cut into other pieces, and so it's just these like little block size? Or no, it's on purpose.
It's on purpose, yeah. So there's a whole other podcast, but there's a house actually built this way in Kansas that was built is like LEED platinum house.
Field trip.
So we'll have to talk about that next time. But so yeah, CLT is pretty much just the coolest thing ever.
Interesting.
So there's different species. There's different grading. There's architectural grading. Just like any other built-up thing, like a glue laminated beam, you have tension lambs on the bottom, and those are a lot nicer. And then in between, right, they're not really taking tension compression as much if you look at your section cut.
Yeah.
So those aren't the nicest pieces. And then like with architectural grade CLT, they grade it differently, and it's more expensive, but you can get it however you want, just like a glue laminated beam.
Interesting. What does the lateral system look like in higher rise wood structure? Can the wood support?
Yeah, so they currently, so you can do currently CLT isn't codified at all for seismic systems.
Okay.
You can use an R1 and go for it. And so if you're, let's say, in a low seismic region, maybe that would work. But the issue comes down to how the panels are crazy stiff. I mean, it's almost acting like concrete. And so connecting the panels is the weak point. There's 4 failure modes. Kind of global rotation, so all the panels at the same time rotate, and so you have this hold down force that you're trying to resist. There's also rocking, so like your bottom panel rotates, but the panel above it also is rotating. So you have like now those. You have sliding of all the panels, so each panel can slide independently of the other one, so that needs to be resisted. And then you have in-plane wall deformation, which would be like what you'd look at for your typical shear wall. It's all together and it's deforming as one. And so there's these modes of how the walls trying to work together. There's been a lot of testing. They have not codified an R value. They have not published enough about it to be able to go off of it.
Yeah.
There is FEMA documentation that allows you to, ASC 710 that pretty much says if you can justify it, we'll do it.
Make it work.
So you have to do peer reviews and whatnot. The testing I saw, which a lot of it's coming out of Japan, they did a 3-story CLT house, walls, floors, roof, all CLT.
Cool.
And they loaded it, and they compared it to a house stick framed, same exact house.
Oh, I mean,
and it came out. It was actually very similar.
Really?
Yeah, from like their testing, it was a little bit more rigid, but it came out to be kind of similar. And I'm thinking because there's not a lot of load, like mass, right? We're doing seismic testing, so sure the panels weigh a little bit more, but you're not seeing like we're talking, if you go to a 12-story tower.
This test was seismic?
Yeah. No, these are all seismic. Yeah. Wind is understood a lot more because you're not looking at your response modification factor. You don't have that, right? You could have, your guess factor with wind is dependent on your frequency of your building sometimes, or you can just assume values so you don't have to. But so I believe with a rigid building you can assume 0.85 for your gust factor. That's the only thing material specific that would really affect your wind factors is my understanding of wind. But so seismically is the issue. So the Northwest is what wants to use CLT the most. Like they have the funds. The wood,
the
because
trees.
the wood's right there.
Yeah.
And wood is super renewable. The United States,
where it can be grown well, right? I mean,
correct.
We're probably not going to see a ton of this in Colorado because to ship wood down here,
correct. It's more of a premium.
Yeah.
They're currently right, supply and demand. The more supply there becomes,
kind of limited supply though. I mean, you can't have many more forests. Like there's a lot of forests that are logged.
Well, I'm saying there's a big backlog for manufacturers right now. So I think if once they get caught up, there's more manufacturers, there's more competition, the price comes down. And maybe, let's say in Alabama, right? Alabama is probably cheaper to ship to Colorado than British Columbia.
Yeah.
Because you have to cross borders and all, to get down here, so it's time. So, Alabama, once that plant becomes active and is PRG 320 certified, like maybe Colorado's all, going to start booming. Colorado does have, I believe, a handful of CLT buildings. So, but going back to the lateral system.
Yeah.
Majority of high-rise CLT, say floor systems, you're seeing concrete shear walls, mostly core systems, and then brace frames and moment frames. So they're still getting the other building materials in there. There's a thing called it's done in the precast world a little bit. It's a precast rocking, post-tension rocking wall.
Oh, I saw this.
Yeah, so they've...
That thing moves a lot.
It moves a lot. So that is also something that has been discussed in the world of CLT.
Yeah.
You're taking a rigid panel and you're doing a rocking wall out of it. So you're allowing it to deform.
Yeah.
Like you're accepting
There's a cool
that.
video. Have you seen... Okay, we should put that in the show notes. This is like a really neat system for seismic resistance, but man, it moves.
I don't think you can meet story drift requirements.
No way.
So anyway, so that's another proposed system. An interesting thing is one of the first jurisdictions that allowed CLT into it because it was such a new building material, wasn't in any codes. would not approve it as a floor system unless they sheathed it for a diaphragm.
Oh man.
How do you what? There's very obvious like connections. So connecting the panels, they butt up against each other, and then they notch out the tops, and they just lay a piece of plywood in between, and they just nail it to make the splice.
Is that it?
That's it.
I was thinking it might be like a weld connection or something. Honestly, like there's some piece of steel and
There's no, and then like that's where a girder would sit, right? So
Yeah.
it's bearing on a girder, so it's not going to get differential there, and then that's your shear transfer. But so even with all of that, the jurisdiction still wanted them to sheathe a 5.5-inch thick plate of wood. I mean, think about
how. I mean, this probably changes, but I'm just thinking like connection between these things. Okay, let's say we're connecting walls,
that.
right? Vertical panels. Do they do the same thing? They notch out a little bit and put in like a 3/4 inch.
This is where steel comes in.
Okay.
Yeah, so the change in direction usually is where they put in steel. So like wall panels will have steel, and Simpson just came out with a bunch of connections.
Oh yeah, they're
Of
ready.
course, they're all over this, and it's
Probably
pretty much
those
like
things designed years ago and just ready to send them out.
it's pretty much just like an L angle.
Okay.
And it's just a gauged material.
Yeah.
And really tall and long and just screwed like no other.
Mm-hmm.
The crazy thing, so screwing in the panels into your supporting elements, they use like 8 to 10 inch to 12-inch screws. Like super, like think how long and deep your
Whoa.
panels are, right?
Yeah.
So they go through, yeah. You have to have some nice drills. I heard
Good
you
strong
should not
drills.
stop while you're drilling. You just keep the momentum rolling. I was actually talking to a contractor that did a project, and he was saying that they started like going through drills and
Like burning out drills.
burning out motors and drills by placing these screws. And so they went and bought a whole bunch of Hilti drills because Hilti has a lifetime warranty on their motors. So they just kept sending them back to Hilti and getting new drills. I thought that was kind of fun.
Yeah.
They need a CLT drill now because they can't go through those long screws. But anyway, so the other big thing with CLT is there's a whole handbook. The CLT handbook, I believe it's like 12 volumes. It goes through every level of everything. Seismically, it talks through the FEMA procedures and how ASC 710 allows that, and all it kind of walks you through how to do everything.
Is there still the same coefficients, like thinking a duration factor when you're dealing with
There is,
heavy
yeah.
timber? Yeah.
Yep.
Okay.
Yeah. All those factors. There is
I think,
still those
like,
factors within all that
Wet
material.
use basically never comes up, right? That's more or less in water. You know,
Yes.
high temperature, that is manufacturing style. That
Correct.
is not just Arizona.
So there's actually CLT has been in the construction world in a long time, as they lay them down to run equipment over,
Oh yeah.
like
I've seen that, yeah.
They'll instead of putting down rock and stuff, they'll just lay these panels down and just drive over them. So CLT's been in the U.S. for a while.
And I just got to take them off the ground and put them on the building.
Got to put them on the building.
It's
so
easy.
I think it's really exciting to see this new building material. It's being used more and more. I think it's being driven by owners a lot. They're seeing
Yeah.
pictures and
They
stuff.
like it.
Architects are loving it. I mean,
Yeah.
you look up and all you see is these big wood girders, and you see wood columns, and then now the whole floor system's wood.
That's cool.
With that though is there is other wood floor systems like in the sense like this NLT, and is nail laminated timber, and they take like a 2x6 and just kind of layer them next to each other, and there's your panel that has a lot of shrinkage issues.
Well, CLT doesn't because of the cross laminated.
Exactly, yeah. In an NLT building, your diaphragm can shrink depending on how long it is, 1/2 an inch to an inch, you have to account for that. And then they have dowel laminated timber, which is like NLT, instead of nails, it's doweled together. That's also not codified though.
It is, this is sort of going back to those coefficients, but is
Yeah.
relaxation an issue with CLT?
Like creep?
Like creep.
I think there is a little creep issue. I don't think it's very major though.
Okay.
But within those CLT handbooks, they discussed creep.
Huh.
So
Like,
those are
an
free
old
to
barn
download.
roof that is just totally sagged in.
Yeah.
That beam is fine. It's just strained because as the wood grains move apart, they
Right.
can.
And that's where
slide a
that
little
cross
bit.
laminated
Helps out.
And then it's glued together and everything. So
Okay.
and in the code, it's called CLT is now in the code, but like for NLT, they don't specifically call it NLT. It's called mechanically fastened timber or whatever. So I guess that's a big. A lot of people don't think they can use NLT because it's not specifically stated in the code, but it is in a different manner that's more broad.
And there's a couple mechanically fastened systems I've seen with sort of like dowel combinations. It might not be nails, but it's some wood in a row, doweled on the top and pinned on the bottom. I saw a couple diagrams of this.
Yeah.
So
yeah, there's bunch
some
of
systems out there.
Absolutely. So yeah, I think the market's gonna be growing for CLT. I think designers are gonna. It's important if you're a practicing engineer to stay up to date with everything, and CLT is one that's gonna jump in. I was lucky to have some experience working on was the largest at the time mass timber project in the United States with CLT. It's a 5-story building, so I got to have a little bit of a taste of it. And got to work on that. It's now been surpassed by many buildings, but it's a really cool building system and material.
Yeah. Sweet.
Yeah. The process of of using it is pretty interesting. It's just like your open web steel joist. It's not design. You don't design it.
Really?
Yeah.
I mean, I would almost pair it more like a precast element.
Right.
Like the open web steel joist, but you can't just go cutting holes in it, right? Everything has to be
You bring up a very good point.
predetermined, like precast.
Yeah. So all your MEP needs to be coordinated prior to fabrication of the panels. And here's another cool thing. The panel designers or the panel companies, the CLT companies, have these massive CNC machines that mill out the panels. So all your openings and everything are milled with a CNC machine.
So like your outlets and wiring, electrical, everything is milled out.
Yeah, it's all vertical. They don't do horizontal right now. There's been talk of like if you left out one lamb and you could, or a couple pieces in one of the layers, you could run conduit through it. There is a Rocky Mountain Institute structure in Colorado that they did something similar like that. I think they used 2 CLT panels with a gap in between, so they could run all that kind of stuff, MEP through there. But yeah, you spec the loads for the connections. They do all the connections.
Okay.
You spec just like a precast. You'd say what you'd want to use, right? So you would say, 5.5 inch panel, this width, this length to work with my column grid, and then you'd own the columns and the girders and the lateral system. But they'll go through the final design of those panels. Now, the one thing that's interesting that you and I have dealt with quite a bit with composite floors is vibrations. And vibrations of individual members are understood, like a bay is understood. And you can use the AISC Design Guide 11 with wood to kind of understand how the system's going to work. And that's how the industry has been going. But anything you get beyond just like a bay is really, really, really difficult with CLT. It's not understood very well.
Really?
Similar to steel. Steel has a a lot more understanding, I think, with it because of how much it's used. There's a lot of good like rules of thumb. But with CLT, it's such a new system, and floor and vibrations with wood is especially CLT is a pretty new topic.
Interesting. I feel like, knowing the material properties, you could figure out its vibration natural frequencies fairly easily, but I don't know. I've never done anything with this.
Yeah. That's one of the challenges of it.
Yeah.
Now, if you just have a nice column grid, you're good.
Yeah.
But if you have anything weird and funky, it's a little more difficult. The other thing you're seeing with these floor panels is, as a, let's say, just a concrete floor, right? Someone walking on it, someone drops something, the floor below, you can hear everything.
Yeah.
So the way they've been mitigating that is they'll do CLT. They'll put like a
rigid foam or something, or
like a sound mat, and then they'll pour concrete on it.
Oh, okay.
So you have like a wearing surface, the sound surface, and then like your floor isn't this nice CLT, but your ceiling you can look up and it is. And it's not. It's coming in, very similar to the cost of a composite system. So you want to use it? I can see it on your face.
I'd like to use it sometime.
Yeah.
I'd like to give it a try.
Yeah.
How long do you think it'll take until regular Joe engineer gets his shot in Colorado here?
Oh, 20.
Dang, really?
10. Nah, I don't know
what a
about that,
bummer.
man. I think it's gonna be a little while.
I was hoping next year.
Yeah. Currently in Colorado, it's still a premium.
I bet it'll be for a while.
Yeah. I talked to one of the suppliers in Denver, and he said they're at their yard right now. They have some laying around, like some panels for a project, and they've been sitting there for a few months.
Shoot.
Because
we can go get those.
They're worried about getting them shipped here in a timely manner, so they wanted to set them. They wanted to have them there in time for the building. The building's had some delays, and so they're just kind of sitting there. But I think in Colorado it probably is going to be a little longer until you start seeing that be a consistent material type being used. I mean, you don't see that much wood right now.
Yeah,
for
that's true.
Like a typical 2-story building around here, you don't see it made out of wood.
Yeah, you're right.
Right in the Northwest, you see it made out of wood.
Yeah, always.
And you'll see steel as well, but it's more of a equivalent match out there.
Yeah.
So.
Well, cool.
Yeah. So we went through
let's head to the Northwest and build some CLT.
Little gravity design there. Talk through some seismic stuff, some wind loading. I think our listeners now can pretty much design CLT.
Best of luck.
Yeah,
should go smoothly.
Hey, this should be interesting. I'm currently on a CLT project.
That's right.
Yeah,
that's cool.
So,
well, where is this one?
In Kansas.
How is that?
So it's for a contractor.
Yeah. Okay.
It is. In 2015, IBC is in there as a building material.
Oh, just not as a high-rise building material. Yeah.
Correct.
I see.
So
when was it added to the
This will be a 2-story building.
Okay.
I believe 2015.
Okay.
And also in the NDS at that point.
2015 had a bunch of changes because that was like straw bale and all sorts of weird stuff, right?
Yeah.
Okay.
This is a little bit more reasonable.
This is weird. This is
I don't know.
Anti-weird.
But yeah, so the structure I'm looking at, or I'm working on, is 2-story CLT. They're looking at using either precast or concrete shear walls. Not a core, but just shear walls around the building for kind of architectural reasons. We talked about doing wood shear walls, which is totally fine.
Yeah.
Especially in Kansas, it's all wooden driven. I mean, the mass of the building isn't going to affect too much there. An RF 6.5 for wood shear wall system.
Do you know what the density of wood is? It's
35.
Yeah, that seems right. Yeah, because it's like the specific gravity of around 0.42 to 0.5, and water
it depends what grade.
2 and a 0.4.
Yeah. It depends what type of wood you're using, but I think 35 is a pretty reasonable number. 35 pounds a cubic foot, I think is what it's in. Whatever.
Okay.
Yeah. So I mean you wouldn't want to you wouldn't have a 2-story steel building and use wood shear walls, right?
Yeah. But it's basically a fifth of the weight of concrete.
Right.
So
it's not as heavy. So again, you can track that to the foundation and have savings there.
Yeah.
So it'll be interesting. I think we should talk more in the next few months about CLT
what kind of pops
as I'm
up.
working through it. You know, It'll be interesting. I mean, 2-story building. We have the second floor and the roof that'll be made out of it.
That's cool.
And you know, it's still a pretty new material. There'll still be things kind of to work through, and
Certainly for the contractors, it'll, I assume, be the first time.
yeah. That's the company is a contractor, and they have in-house architects that are really really into
I bet.
CLT. Really want to see it be used. I believe there's maybe one. I don't know this for sure, but I'm pretty sure there's at least one building in Kansas out of CLT right now.
What?
So they would be like the second CLT building in the
Second's
whole
so good. I'd
state.
put that on the front door.
Yeah,
Welcome
and
to
they
the
want to go like
second
right
CLT
downtown,
building.
you know, like where they're at. So it'll be really cool to work through. Whether they end up going with CLT right now, that's the direction.
Mm-hmm.
But you know, money is really at the end of the day what drives everything.
Yeah.
So we'll see. But
Cool.
I think we'll maybe get a chat about that again here.
Yeah, hopefully.
Work through that. So
Sweet.
anything, Max? You got
Closing.
Yeah.
Last questions.
any last questions you can think of?
Yeah,
I know you
you
haven't
hit it
had
all
an
pretty
opportunity
well.
yet, but
I need to play around with this some.
okay,
I
and
wanna.
we'll come back to it.
Yeah, we'll come back to this. Let's revisit in a couple months. Get some experience with this. I want to do some CLT work. I'll just look over your shoulder, I guess. And yeah.
All right. Well, that sounds good. Well, thanks for joining us this week. As always, down in all the notes on whatever platform you're looking at here has all of our information, and please reach out to us to talk to about any topic, not only ones that we've talked about, but really anything
Anything you're
structural
interested in.
engineering related.
And we'll have a little CLT write-up on our website blog with links to, I mean, I guess if you're listening to this, you already got there, so you don't need links to the podcast.
Right. But if you
tired.
go out to our website, there'll be a lot more information
Yeah.
there. We'll have the CLT handbook link posted there, so you can go check that out. We'll have the APA PRG 320 link there, so you can go get all the information you need to be able to design with CLT. So hopefully
Cool.
you guys found this informational, and we'll catch you later.
See ya.